awesome poem, Cross the Gap.
That's good.
It uses these really cool, almost electric metaphors to explore how the brain works. And I'm excited to break it down with you.
Yeah, I'm excited too. I think it's super interesting how a poem can get at all these scientific ideas with such a cool, like, elegance to it.
Yeah, totally. It's like, for instance, right at the beginning, the poem talks about a gap between brain cells.
Yeah.
Which, it sounds simple,
Right.
but it points to this huge change in how we understand the brain.
Mm-hmm.
It wasn't always so obvious, right?
No, it was definitely a big shift. Like back in the day, scientists mostly thought that the nervous system was just like one big thing.
Oh, wow.
This whole connected web. Yeah, like a giant net. But then this guy, Ramon E. Cajal, I don't know if you've heard of him.
Yeah, vaguely.
Pioneering neuroscientist. He used this technique called Golgi staining to actually see the individual nerve cells.
Golgi staining. Oh, man. That rings a bell. It's like way back in bio class for me.
Yeah, it's been a while.
Remind me how that works.
So basically what it does is it stains just like a random set of neurons, but it stains them like completely.
Oh, interesting.
So you can see the whole structure against this background.
Got it.
It's like if you're looking at a super dense forest,
Right.
and then suddenly you could see a few of the trees perfectly, like every branch, all the roots.
Wow.
And that's what Cajal saw through the microscope. It like totally revolutionized neuroscience, really, because he realized, oh, it's not a continuous web at all. It's these separate little cells, neurons, separated by tiny gaps. And we call those gaps synapses.
Synapses. Okay, yeah. Now I remember that term.
Yeah.
And so those gaps, they're not just empty space, right?
No, not at all.
The gap across that space.
Mm-hmm.
It's a really cool image, but I'm curious, like, what's actually going on there?
I know, it is a great image. It's like, it really gets at the heart of how those synapses work. Those liquid messengers are actually chemicals, neurotransmitters. So when like a signal travels down a neuron, it's basically an electrical pulse.
Okay.
But that can't jump the gap.
Right.
So what happens is when the pulse gets to the end of the neuron, it's like boom, it sets off these neurotransmitters. Like imagine tiny little packets of information being launched across the synapse.
Wow.
And then they land on the next neuron, and that starts a new electrical signal to keep the whole thing moving. It's like, I don't know, a relay race where runners are passing off the baton.
As you're explaining this, it's like my brain is sending all these signals and releasing all these neurotransmitters just so I can understand what you're saying. It's kind of mind-blowing when you think about it.
I know. And it's not just understanding, it's everything. Every thought, every memory you have, every emotion, it all comes down to this little dance of signals between your neurons.
It's wild.
It's wild. And speaking of memory, let's go back to that line in the poem about the brain starting as a blank sheet and then developing circuits.
Okay.
What do you think about when you hear that?
Well, it makes me think of just how adaptable our brains are. Like constantly learning, constantly growing based on everything we do, everything we experience.
Mm-hmm.
So, like right now we're talking about this poem.
Right.
And as we're talking, new connections are forming in our brain, pathways are being strengthened, stuff about neuroscience and poetry and all that.
The brain is like constantly rewiring itself. It's responding to information, it's responding to experiences. I always say it's not a static organ, it's a dynamic, ever-changing landscape.
That's a great way to put it.
And that's what lets us learn new things, remember things, even recover from injuries.
And that's a good point, because the poem actually mentions how fragile the brain is, how it can be damaged. But it also talks about its ability to rewire, to kind of find new paths when the old ones are blocked.
Exactly. It's like, have you ever thought about it like a city's transportation system? Say one road is closed for construction.
Yeah.
You just take a detour. Traffic's got to be rerouted. And that's kind of like what the brain does if, say, there's damage to one pathway, like from a stroke or something.
Oh, I see.
The brain can be like, okay, we're going to find a new route. And experience is like the driver.
Yeah, okay.
The more you challenge your brain, the more you learn new things, the more you do different things, the more those pathways are strengthened and your brain gets more adaptable.
So it's like learning new things and challenging ourselves is basically a workout for our brains.
The poem goes on to talk about like intelligence and memory, how the brain is just incredible at processing information. It even uses the phrase massive data crunching, which I think is a pretty accurate way to think about what's going on up there.
Yeah. And to think all that's happening right now and we don't even notice it. Processing language, recognizing faces, making decisions, all while effortlessly keeping our body going.
It's crazy. It's like having a supercomputer in our heads.
It really is.
And you want to know what's even more amazing? This supercomputer, it runs on like 20 watts of power. That's less than a light bulb.
Wow.
It's ridiculously efficient. If we could build computers that were that efficient.
It would change everything.
Totally.
So we've talked about the gaps, the rewiring, just the raw processing power of the brain. But the poem kind of goes even deeper. It calls the brain humanity's spark, a flame in the arc. That's such a powerful image. And I think it's getting at something really deep. What do you think?
Oh, definitely. Definitely. I think the poet is trying to get at that essence of consciousness, that mystery of what makes us aware of ourselves and everything around us. It's what makes us feel, joy, sadness, wonder, all those things.
It's fascinating because, we can break down the mechanics, how neurons talk to each other and all.
Yeah.
But how do we get from there to actual feelings, to the feeling of being me? That's a whole other mystery.
You've hit on one of the biggest questions in neuroscience and philosophy. It's the mind-body problem. How do we get from the physical stuff of the brain to the non-physical experience of consciousness?
Right.
And we don't have a definitive answer yet. There are theories that say consciousness comes out of the complex interaction of billions of neurons. And then there are others that say that maybe consciousness is like a fundamental property of the universe, like gravity or electromagnetism.
Fascinating.
It's a real head-scratcher.
It is. So all these thoughts we're having right now, as we're exploring this poem, our curiosity, everything, it's all coming from this incredible and kind of mysterious organ.
Yeah, I mean, it really makes you appreciate just how complex and powerful the brain is.
It does. It really does.
The brain is like a whole universe unto itself, full of these amazing things we're just starting to understand. And that's part of what makes neuroscience so great. It's a field of constant discovery.
After today, after this deep dive, I don't think I'll ever look at my brain the same way again. There's this one line from the poem that really stuck with me. It says, "The brain holds the past and the future in one fragile hold."
Yeah.
It makes me think, about how our memories make us who we are, how our dreams and hopes, they drive what we do. And this incredible organ is the bridge between all of it. What about you? What does that make you think about?
It reminds me that we each have this incredible power to shape our own brains. And in turn shape our own lives, really. Every experience we have, every interaction, every thought, it all contributes to, the story of our brain.
And that is a powerful thought to end on.